Hello everyone, hope you had a good day so far. It's your boy. Basically today I wanted to do something a little different. I want to focus on a Houdini tutorial in which you are designing 3D jewelry that you can easily send in real world measurements to a jeweler to make your design come to life and be able to iterate a lot to it in 3D before sending it through and spending a lot of time and money to get something working in real life. So this, give or take, is going to be the design that we'll be looking for. We will be simulating the chain in 3 pieces, the top piece, middle piece, and the end piece in here, adding the coins in after, all through Vellum, and then some post-processing in the end. So yeah, let's get straight into it. First and foremost, I used an actual 3D photogrammetry scan. So I have actual real-life measurements to use for my necklace, and that helps me get a grounded measurement to be able to send to the jeweler afterwards. I used the iPhone application called Polycam. All you need to do is open the app, log in, click the plus button on the bottom right, move around your subject or model in 3 perspectives, for instance, 1 from above, 1 from the middle, and 1 from the bottom. Everything is done pretty much automatically, and then you simply click on download or upload it. It'll take a second to process, around 10-ish minutes. After that, you can send it through to your email. After finishing off the workflow on your phone, you will get an email if you select it to export it or send it through your email, in which you can just click export, log in with your Google, and then click, again, if you're using it for free, for the GLTF version, and then simply export it and download it whatever you want. So now all we need to do is import the GLTFC by going to import GLTFC, finding the file, importing it in. And now all we need to do is some simple post-processing. Let's create another geo node and then add an object merge. Through there, we go to our GLB node, go to the geo inside it, click accept. Now, the simplest way to grab this over, before we get into that, the scale sometimes is a little weird with Polyframe at least. Some files were a scale of 100, this one was scale 10 extra. Basically, you use the shoulders as a unit of measurement. Shoulders are, from shoulder to shoulder, is around 40 centimeters by default, so I use that as a basis. We want to flip this in the Z axis, and then we can simply add a cube to then boolean the shape out. We go to our box, keep our scene, move it around, kind of eyeball where we need to boolean out, make the scale a little bigger, and I feel like this give or take works. We boolean it out, so let's do A from B. Should have been the other way around, but here we are. And now that we have this file in here, we can then delete this outer shell, and here we have our inner shell that we can start working on and using it as a real life, real measurement basis or reference for you to start modeling the necklace around. I took the liberty to replace and post-process the model I did of my wife's, simply because she wasn't comfortable showing her entire body on there. Generally, let's zoom in a little. First thing I did is a small remesh, and that's to keep the geometry a little equidistant, or better and more high res for the Vellum simulation to simulate on. And then I did some easy clipping top and bottom to get the shape in here. Now, let's start looking at the necklace bit, understanding how many chunks we need to split it to and how we design it moving forward. So we have, and let me draw on top of this now, zoom it in a little. We have the left side or right side, depending on where you want to look at the perspective. We have the right side. These two are connected in the back by a clasp. I'm not really going to add the clasp simply because it's relevant to my current sample. I'm just going to fuse the points in the back. We have a single line of necklace that drapes first, so that's middle point 1, or let's be a programmer and call it mid 0.
we have the one in between, and that's 1, and then we have the one under, and that's 2. So we understand that we have 1 line, 2 lines, 3, 4, 5 primitive lines that we need to work with that are separate but connected together. Let's see how we're going to do that. So, as we mentioned it before, I specifically use the word line because this is exactly what we're going to use. So, if I drop in a line node in here, we can see that it's pointing upwards. We want it to be facing the x-axis. So we do 1 and then 0. So now it's facing to the right. The length, give or take, shoulder to shoulder is 40. Around the next area is around 20. We need both of those to drape around the neck. All of this is purely theoretical, and we can size it up and down in Houdini because everything's procedural. This is the reason I chose Houdini for something like this rather than just curve modeling in Maya, for instance. So let me set the length of this one bit of the necklace to 20. Easy way that I thought of getting nice thick geometry on the lines, regardless of how much I size them, is instead of just manually adding the points in, what I could do is copy the length parameter and then just simply pasting the relative reference to the points and then multiplying it by 2. And that gave me a really nice amount of geo that, regardless of how much I made the line bigger or smaller, it stays quite nice and equidistant. So this is the middle line, the original mid-0 line. I will consider this the middle part. I want one on the left and one on the right. So what I'm simply gonna do is add a transform. And that would be my left point. We already know that this has the length of 20. So we copy the parameter again. And we simply move this extra transformed line a bit to the left. So we paste the relative references here. And this one moved to the right. We just add a minus and we have our left piece. Then let's do our right piece by simply removing the negation. And if I quickly merge these 3 on here, we can quickly see that now we have 3 parts that are separate. To simply visualize them, and for no other reason, I'm just gonna add a quick color. Now if we remove the point, you can see we have a very clear distinction in between them. I'm also gonna group them to make sure I understand which piece is what. It'll help us later on by masking out different pieces. So this is left group. So now we have it quite nice and organized. If we go to our groups, primitive, we have left, middle, and right. So now that we have this in, we can start thinking about how we're gonna add the pieces in front. We did this piece, the one in the middle, the one on the right, but we're still missing this one and the one right under it. A good sip of coffee. Now we want to make sure these 3 pieces are fused together so they become a single piece rather than 3 separated pieces. I might show why I did that in a bit. Now they're all merged together, as you can see here. I'm not sure with YouTube compression, but we went from the points having a harsh break off to fusing together. And now a really cool thing I can get straight out of the box from my fuse is getting the points that got fused from the middle part. So technically getting this connection point and this connection point for free. And we can name this mid connection point with an S. And if we quickly visualize this group by going to the points, we can see that we literally get these 2 points basically for free. And yes, I did just point at my monitor thinking you could see that as well. That is very true. I did that. Let's move on with life. Now we need the 2 extra lines that go in front of it. Simple concept as well. I'm just gonna copy pasta this one. What I'm gonna do is simply move it a little forward. Let's merge them together. and I want another one as well. Each one needs to be a little more forward from the one before it, and that's on the z-axis. And that's also, give or take, mostly just for us to visualize it, but it'll also help us a little with the simulation afterwards. Same thing as we did with these. I'm just gonna add some colors, and I'm gonna add the group for each, just so it's easier to work with them. And now if we merge them together, we can see we have these nice points and groups that we can start working with. Now, we have them laid down like a real necklace would be. Because don't forget, this is very similar to UV wrapping. The necklace itself is flat, and then when you wrap it around your neck, this is when it's taking the form. We also need to get the points, or group the points, the first point in this geometry and the last point in this geometry. So then I add an attribute wrangle node, and what I do here is I want an integer group, and I would name it group underscore mid ends. This is the first one of the mids, so mid one ends. And then what I would do, Vex provides you with a very useful function. It's called neighboring count or neighbor count. And basically what this means is simply each point in here has X amount of neighbors, so points that are connected to it. If you're the last point in the geometry, that means you only have a single neighbor because you're only connected to a single point. Therefore, we can get the point that is disconnected or on each end of this line. And I will do just that, so neighbor count. The first parameter is which geometry are we doing the work on, so that's the input 0. And then I want to loop through each point and find out which point has 0 neighbors, or a single neighbor, apologies. And here it's basically looping over each one of these points. So I'm using the number of the current point that this is looping on. And is it equal to 1? So do we only have a single neighbor? If the answer is yes, then just add it as a group. I also forgot a single parenthesis, and here we go. And just to quickly visualize that this worked, again, we go back to our group selection, mid ends, we can see that the left and right points are now highlighted. I'm not sure how well this will show in the YouTube compression, but 0.0 and 0.39 are indeed in this group. If we add more points, this will always go back to being grouped correctly. I'm going to do the exact same thing for the second attribute wrangle, and this will be mid 2 ends. So now we have these points in here. We have the mid connection points, we have the mid 2 ends and the mid 1 ends. To explain this a little further, we have all 3 points that we want to connect together. Pretty sweet. Now we need to add a bend node to turn these flat lines into a circular shape akin to a necklace. So what I will do is I will add a bend modifier or a bend node. And in here, as you can see, it sort of bends the mesh that we're working with. What we're going to do is change our up vector, because you're genuinely saying what is facing upwards, and we want the y-axis to be up. And in which direction do I want to be curving this around? It's not the z-axis, but rather the x-axis as well. And as you can see, now it's also a little weird in here as it's not collecting all of them. And what Houdini provides for you very nicely in the viewer states is you can just click N and fit the capture. And now as you can see, it's bending all of it correctly. I'm going to do 360 for a full circle. We realize that we did it the other way around because the necklace is facing inwards. We undo that and get this shape instead. Now what we're going to do, have a look again at our bust, our collider, and align this piece of necklace to be around the neck. So I'm just going to add the transform, move pivot to centroid, or what I can do is center. And after centering, I can move it to centroid. I can move it to the neck, apologies. do a rotation, minus 180, and that is minus many thousands, minus 180, and then just have a quick look that it actually aligns with the neck. There's quite a bunch of ways to make this align a lot better, but for the sake of this example, I can just eyeball it and it'll do the job just fine. Cool, so now we have the shape, the body collider, and the necklace laid on top of it. We can now simulate it on the geometry. In Houdini, Vellum is an absolute legend of a solver, and there's so much to work with. I'm gonna do a Vellum configure hair. You're gonna say, well, this is a necklace, why are you using a hair modifier? My answer to that is I'm not. It's just closer to string, and this is what I'm gonna use because a necklace is technically a string. If you're looking to add chains and have each chain react pitch perfect with each other chain, you might need to use RBDs and then spawn or spam a bunch of circles inside each one of these chains, and that's how they'll collide with each other. But for the sake of this example, a string did the job just fine. So I'm going to use a string modifier, a string Vellum constraint, apologies. What I'm going to do in here, without too much focus or worry, to be honest, is just set the mass to be uniform, the thickness to be uniform as well, because it's a base necklace. It all has the same material, so there's not much to happen here. The stretch in here, it's a solid necklace, so I don't want it to be stretching up and down. It's not a string, it's not a rubber band. So I'm gonna higher the stiffness quite a lot. These numbers in here are just extra modifiers, so you don't have to use massive numbers. So for instance, this would make minus 10. Imagine grabbing the 0 and moving it to the left 10 times. So it would be 0.001 in this exact example. Damping ratio is basically, we chose the stiffness to be super stiff. How much do you want to damp that value? How much do you want to reduce this value in percentage? I don't want it to be stretching at all, so I'm going to set it as 0. We need to use our collider, our original model in here. And we added in the collision geometry bit. And now we need to add the solver to actually do the solving in here, to actually do the magic and simulate this. We change our solver mode from minimal grains and fluid to full. Now you can see our collision and our necklace meshes available in here. And for the sake of this example, let's see how this looks by just simulating right now. If we play the simulation, you can see a lot of cutting is happening here. It's simulating, it's draping, so we're doing something right, however, not just right enough. As we fused these green points before, we didn't fuse it after we did the bending again. So the back point is not clasped together. So let's do just that. Simply because there's no other points that are super close to each other, adding a fuse just by itself will take care of the back part. Let's have a look at the solver again. Go back to the beginning and play. Now we can see this part of the necklace is working just well, which is perfectly fine. But now these two pieces are flying out. We need to connect them as well to the pieces. Now we can always do another fuse and fuse these 2 points to the piece in here, but that'll be a little messy. What we can do, and what Vellum provides for us quite nicely, is more constraints, and it's called a weld point. It's literally taking a welder and doing and connecting these 2 points together. And this is where I said above that I'm gonna get the outer points for each one of these, as these are the points I will be connecting the necklace to, and they're quite conveniently placed in groups. So on the first one, in my weld points, the base geometry that I want to be connecting to would be our mid ends. Let's switch the points on both. The connection points, the original connection points, and it's gonna be glued to the mid one ends. Then I'm gonna go to my Vellum solver and simply just play it again until I get a stable-ish shape happening in here. And on this case, frame 240, I'm pretty happy with what I got, and I can pretty much work with this. So I will file cache it to have it stored, to not simulate it each time. Won't really change much, just keep it directly on the disk. Now that we have this, we can move into the second point, in which it's actually spanning geometry or copying geometry on these points and working with them accordingly. So this is technically right now our simmed lines. What we will do is we will add a time shift node. This node always confused me, but it basically says just lock it to a single frame. If you click Control and Shift on your keyboard and then click on any attribute or expression in Houdini, it will stop it from being keyframed or of it being using a certain code or node. If you click on it, you can see it was on $F, which means it's specifically which frame we're on in the sequencer or the playback bar on the bottom. So Control Shift to remove it. And this is where we want it to be in the last frame on here. Now we have our simulated lines. From there, if we scroll in here a little, we can have a look that there's a lot of these random attributes that are necessary for the simulation, but we personally don't care about. So we can clean those out, remove the attributes, but we want to keep our colors just for the sake of us having a better visualization. I will want some normals on these bad boys, so I'm gonna use a polyframe. If I visualize the normals, you can see polyframe will add normals facing downwards. Now, if we want our normals to face other directions, polyframe also allows us to do all of that. What we can do, and for the sake of this visualization, is I will add n on each one of these, and I will scroll by them one by one to see what we get or what result we get by changing between normal, tangent, and bitangent. So if we have it set only on the normal, they're facing all downwards. If we use tangent, we can see that they're moving, and let me just make this a little longer for the sake of this example. They're all moving along the curve. And if we use a bitangent, they're all facing outwards. And just by seeing this visualization in here, you already have an idea that this is exactly what we can use to span these points across. Now that we have our connection points and the visualization of how it will look like and how we can use it, we can move ahead and start adding and spanning geometry on top. So we need multiple pieces to work with here. We need the actual necklace chain, and we need the gold coins that will go on top. At this point, this is no longer a simulation sort of tutorial. It's just spanning objects on top and different ways to get the same result in the end, pretty much. Let's start with the chains. An easy way I found to make the chain shape in itself is to simply use a font node and adding a simple 0 on here. And it just gives you this nice shape that you can work with, and there's these different fonts to work. So I just chose Agency FB Bold. I'm gonna make it face upwards, so -90. I want the geometry to be a little cleaner, so I'm just gonna add a remesh before doing any of the other operations. We get this nice geometry going. I will do a poly extrude to push it upwards. There we go. Make sure you output the back. Now I want the bevel to only happen on the hard edges and not on each one of these points. So what I can very easily do is add a group node, change the group type to edges, and include the by edges. And this way you're saying what is the difference or what is the current angle of these edges. And you can just go on min edge angle and higher it up a little. anything under 90, because this is the angle that you're looking for. And then you can do your bevel only on these hard edges. It's by going to the group and adding the distance of the bevel. And there we go, a really nice shape going on. Now, this is a single piece of these chains, and this is something that we can start and use as a base. We will do a quick back. And we want two versions of this, one that's flat and one that's interconnected with it. So let's just do that really quickly by simply grabbing this part. Actually, let's add a transform right above it, just so we can change the scale however we want. Scale. And then in here, we just grab another one of these points and we simply rotate it on, I think, the Z axis, correct? And then I will merge these 2 points together. So we get this shape. This is sort of the interlocking, interconnected shape. I feel like this thickness isn't quite enough. This is the beauty of Houdini. You can just go back to the poly extrude and add a little bit of thickness. We're simply going to add a null and name this chain link. I'm going to be adding another transform on here to rotate it, or to be able to rotate it in different axes so it works better with our chain. Now for our chain, we want them to be not facing outwards like we'd expect of our coins, but we want them to be in, like, following along the curve. So instead of using this polyframe and the bitangent, I will be using the tangent as our normal. And then I'm gonna do the chain Houdini node, which does all the magic for us. We connect them on here. And as you can see, we already, give or take, have the shape that we're exactly looking for. We change the alignment from Z to Y. And this way, we already have the shape that we're looking for again. We change the piece spacing, so they're interlocked together. And there we go. We have a big cash money chain working on here. What I want to do is change the size of each one of these to make it a lot thinner than what it currently is, or a lot bigger if that's what you're looking for. And this, give or take, works for my specific example. The beauty about Houdini is at any point you don't like the shape of this specific chain, you can just change the font and there you have another shape of the chain that you can work with. And this is what is really powerful about Houdini and why I like using it rather than Maya or something else for examples like this. I will add a null in here and name this chain simmed geometry. Now we need to add the gold coins to this chain, but first we need to create the gold coins. We already made a single chain, a chain link, so we have a single non-connected piece of a single chain in here, and we're going to use that to add to our coin, to connect our coin to the necklace. So I'm going to add a cylinder. Lab cylinder does the job. I'm going to make this cylinder a lot smaller, remove the bajillion divisions that we have in here, and add end caps. Same concept that we did originally with the group and then the poly bevel. We just copy paste it straight as, and you see we get these nice bubbles. Now we're gonna add this chain that we just created to our cylinder on here by simply merging them. Now you can't see much as the chain is facing right under it. Now this is where we need to think about real life measurements. A gold coin size by default is 1.6 centimeters. There's different sizes, there's bigger, there's smaller, but the default one is 1.6 centimeters. So we want 1.6 centimeters, but this is radius, not diameter. So we simply just divide it by 2 on here, and we get the correct radius. We need to move up or move down the coin, either or. So let's move down the coin in this case to match this chain. And then we need to also rotate the chain piece in order to be connected to it. As you can see, I always switch the orientations. Move it a little upwards to make some sense, and for it to be connected with it. There we go. Now this is one piece of chain, one piece of gold that's connected to our chain. We can probably do a center on here to make it match up better, but I'm just going to do it manually and just work with it as is. And then, just for the sake of being correct, I'm going to add a yellow color just so we can visualize it a little better. I'm going to add a null, and then I'm going to name this my gold coin. So now we have a chain link. We have it connected to our chain, and we have a gold coin ready to spam on top of this chain. We can take our polyframe here, and we can start adding the gold coins to the chain. We only care about these 3 bottom points. So what we're going to do is we're going to add a blast node, delete non-selected, and select this one, and the one under. Thankfully, we already have the groups for that, and that is mid 0, mid 1, and mid 2. So now we blasted everything that is not the specific points that we're looking for. There we go. We're going to add a quick merge, so these top points get ignored. I can do this in multiple ways. A fuse, apologies, but just fusing them together does the job. If you have a quick look, and here, this is a specific point 39, and here it's a bunch of overlapping points. Okay, now we need to decide how many gold coins go on top of each one of the chains. We can either do a resample, in which they will all be equidistant and might not be exactly what we're looking for, or my favorite approach, which is to do a blast to select all 3 of them separately. You can also do a group range and simply select one of the base groups and then move forward. But for the sake of my visualization, I like separating the geometry first and then working on each one separately. So I'm going to grab mid 0, and this one will be mid 1, and this one will be mid 2. Grab all of them and delete non-selected. So now you have them separated. Now I can do a group by range. And I can select, for instance, one of each 4 gold coins per point. Now, why I like using this over resampling is you can also offset these points by 1. So you can have this difference or differentiation between each gold coin. And I'll show what I mean specifically right now. Gold coin. And I'll do the exact same thing on each one of them. And then I can merge them again. Let's make sure our normals are still there. As we can see in this specific example, we lost them, and that's because we did our fuse. We don't lose that by removing recompute affected normals. So now we keep them as is. We go back to our merge. Let's hide our normals again. Let's blast all the points that we don't want. Non-selected. Worth doing another fuse, as I still got a small connection on the top bit. And don't recompute the affected normals. And now that we have this, we can copy our gold coins. Let's add an object merge just to have this a little cleaner. And now we can copy points. Geometry goes first, and then the curve afterwards. And this is how we can get these gold coins getting laid up quite nicely on top of it. Now, this is again why I love Houdini so much, is because everything's parametric. We don't lose anything. We can go back to the first necklace or the second necklace if we wish, and either lessen the amount of coins, or if we don't want to, we can just offset it a little to not connect or overlap one of the other coins. You can obviously always do another RBD simulation where you can solve the intersections between them, but in real life you don't really want the gold coins to hit each other, as they will basically scratch them, and that's not something you really want if you want to keep it as a good investment as gold per se. And I will do the same one for the first, just to not get this interlocking coins, and maybe even lower them a little. And I think I'm quite happy with this specific example. Any other coins that you want to remove or you're specifically not happy with, at this point, I would not stress over making everything procedural, as I personally have wasted hours of my life trying to make every single tiny bit procedural, versus just selecting it and deleting it manually, which does the job way better, way faster. So now we have the gold coins on here. And to be honest, we have the chain and we have everything working exactly how we wanted it to. We can simply do a merge in here, connect the other piece, and voila, you have a nice draped chain on top of a nice looking model. Let's do another object merge just to show it as well nicer. Color all of our pieces in here to yellow, just so they match our gold-esque vibes a little better. If it's intersecting by any chance, you can just make the thickness larger in your vellum bit, in your vellum thickness. You can notice that these clasps, for instance, are not really interconnecting with these pieces. You need to remember that our chain node, we changed the uniform piece scale, so it became like 0.3, for instance. You'd basically expect to do the exact same on here to match the actual size of it, and then move it a little forward by simply adding a transform, and then translating downwards to match each chain. Now, sometimes it won't connect 100%. This isn't something I really care about personally, but you can change which point it's going on by playing around with a group range, or simply by moving it left and right. But when it's so far, you really can't see any of that. And yeah, there you go, your gold coins on here. If you want to fix these orientations on the sides, just simulate it as an RBD. I haven't done that myself, but feel free to experiment and do whatever you want with this concept. The best part about all of this is, for instance, we can grab this uniform scale and then paste it as the uniform piece scale as a relative reference. And what you can simply do is now magically you just made all the chains bigger and everything will work accordingly, which I really love having. So yeah, hope this tutorial was useful and hope you learned a thing or two. I couldn't find any tutorials online that did this connecting different pieces of chain together without using RBD or like super specific techniques. And I thought this works well, aligns with how Houdini is meant to simulate strings. And yeah, hope that helped. You have a good one. Take care.